F5 stuff that Microsoft and F5 have partnered on regarding SCCA, the Secure Cloud Computing Architecture. That's the functional requirements document that was put out by DISA. I'm Jason Henderson. I'm from Microsoft. I was one of the primary people from Microsoft designing our solution together. And Michael Coleman, if you want to say something, please be my guest.
Yeah, I'm Michael Coleman. I work with our Army team as an engineer. So if you guys have any sort of technical questions or requirements, you want to talk to us afterwards, feel free to reach out to us. Contact information is on the last slide, one of the last slides as well. And we've got the entire Army team in here. Mary Celestine, retired sergeant major out of NetCom. Doug Powers, we're also with the National Guard. Our entire team. Jason, myself, former Marines. So everyone speaking to you today has experience in one form or another of working with the DoD and supporting the DoD in IT and in cyber.
Yeah, and so I cover all of federal and DoD, so I get to see kind of a wide variety of what customers are doing in the cloud and kind of can use that to reference things that may be happening around the rest of the DoD. We've also got our Army account team here sitting in the back. We've got Rob Bolbatowski, Ronnie Hops just walked in. And so if you guys want to talk about anything specific regarding your accounts and things that you hear today or anything in the future, they're the guys you can contact. Anything that goes cloud, that I can come in and talk to you guys from a technical standpoint on what you're looking to do. So with that, so why are we here? So the biggest hurdle for cloud adoption across the DoD is connectivity. It sounds simple enough, but it's really not. There's all kinds of policies, just like everything else in the DoD. And the biggest thing, obviously, is the DISA CAP or a cloud access point in general. So as we started going through all these policies about a year ago for the SCCA functional requirements document, we kind of quickly realized that we need to create something that's sort of a repeatable deployment that can be referenced as a starting point for everybody across the DoD and kind of give you a little bit more options when it comes to connectivity. So when we did that, we recognize it needs to comply with the current policies. There is a lot of, we'll go in and talk to a lot of different entities across the DoD, and everybody has sort of a different idea of how they want to accomplish security, but it always boils down to you still got to meet that base policy. And if not, you've got to have a good justification for waiver for some specific controls and show that you're mitigating it in a different way. So our goal is to enable DoD cloud adoption. We want to be able to get you guys there. Everybody has mandates to get to the cloud as quickly as possible, and we're just trying to remove those roadblocks for you guys. And so there's obviously a lot of stuff that the cloud does for you when it comes to scalability and your agility and your ability to be able to scale on demand or just deploy architectures in a lot quicker and more secure fashion. So that's what we're trying to do for you here today. So when I decided to look for partners that could actually help us accomplish the security controls that are written in the SCCA FRD, the first people that came to mind, the first group is F5. The reason for that is because F5 has a foothold across the DoD. Everybody's familiar with F5. The current CAP was built with F5 stuff. So when we went to the first meetings with them, they already had all these controls mapped out. They were ahead of the game, and everybody I work with over there is, they've had some experience across the DoD, and they really get what you guys are looking to do, and they're passionate about it. So it made it very easy to work together to actually build this solution out. We had a pretty good effort with some of their other architects actually building this, and it was basically one team, and so it's been really, really valuable for us. So what I'm going to do now is I'm actually going to show you guys, we've actually automated the deployment of this for the whole architecture. I'm going to kick off the demo, and then while that's going in the background, we'll go through the rest of the stuff and actually talk about what this is all doing. I just want to be able to demonstrate that it's really it usually takes about 40 minutes for the whole architecture to complete and come up and be compliant with SCCA. So it's a really good possibility it'll be done by the end of us talking. But if not, I'll show you guys some of the other stuff. So let's go ahead and exit this. So we wrote some documentation. So on the Microsoft side, wrote this blog that kind of talks about what SCCA is, shows some of the mappings of the security controls to F5. It's not showing on the screen. Oh, hold on. So this is what it is. So this is the blog that I was talking about. It talks about all the different stuff within SCCA. It has the links to the actual document. Shows the controls, the requirements, and how they map to the different modules of F5. And obviously, you can, F5 wrote some more in detailed documentation. It's got our diagram. But down here where you actually deploy it, it'll actually take you to the documentation that F5 put together. And in here, you will have a complete step-by-step on how to do this. There's a couple steps that you have to do to enable the deployment. Manually, it takes like maybe 5 minutes. I kind of pre-staged that for today. This will talk about all kinds of the topology and things that F5 is doing for you. But from here, the most important piece is that if you go to the launch deployment, it's actually got the JSON template. So everything in Azure that is deployed on top of JSON. It's infrastructure as code. And so what we did is we wrote all this stuff together and then deploy the machines. And then it'll actually do a configuration script after everything's deployed to actually apply policies on the F5s. So to do that, all you have to do is click on this link right here. It'll log you into Azure Government. And in here, you're just going to pass some parameters to it. So we've filled out some default parameters. You're going to create a resource group. So we'll call it that. We're going to pick the region it's going to deploy to. So the other key to this is that there's FedRAMP high, and they've got impact levels. So DoD has to run an impact level 5. So in here, we do have the ability to be able to deploy it into IL4 regions or IL5 regions, but our best practice, as we'll talk about later, is to deploy it in IL5. That way, if you do have like IL4 workloads, you could pass that up through this stack. It's a more secure cloud to get out to the DISN. If you put it in IL4, you don't want to pass it down and out. So we're going to select DoD East. That's one of our IL5 regions. We also have Central. Here, you're just going to put username and password. So these other, if you see, there's little red stars to the left of these things. These are the things that you have to fill out. What I'm doing right now is the service principal. So this is actually going to give you access to be able to deploy to this app registration. This is the steps that I did before we got up here. This takes about 5 minutes. You can do it through PowerShell, or you can do it through the portal. The documentation I just clicked out of to get to here does show you exactly how to do that. So it's pretty quick and easy. And then the license keys. So here, these are the actual F5 license keys. So there's 4 of them because there's 4 F5 virtual editions in this deployment. Yeah, so all this other stuff that doesn't have a little star next to it, these are parameters that I filled in default parameters for. But you can change. So like if you need to bring your own subnets and you have some sort of IP scheme that you're going to be bringing to the table, you can modify this or modify the names of the subnets as needed. These are just the defaults that we put in here. And so that's pretty much it. Then you just say agree to terms and purchase. It'll validate the template. And then it'll go to the deploy screen, and you just got to click one more button, and there it goes. So deployment's in progress, and now I'm going to let that run in the background, and when we come back, it should be completely completed. So I'll go back to the slide here. So the state of the DoD cloud, right? So there's a ton of barriers when it comes to the adoption, of course. So we've got the cloud access points that you're required to connect through, VDSS, VDMS requirements, FIPS compliance, and then of course you get into like contracting and accreditation, and of course like the workforce skill set. So there's not a ton of people across the DoD that have been doing cloud for a very long time. There's not really realistically a ton of people across the world that have been doing cloud for a very long time. It's pretty new over the last 5 years or so. Contracts and accreditation, that's always a headache. But what we're trying to accomplish here is the technical stuff, and to enable you to actually get through the accreditation a little bit quicker. So there's a couple different options that we always discuss with customers. There's, do we just connect to the DISA CAP, which is the mandated way to connect right now? Do we use some sort of hybrid scenario with that? Or do we stand up our own CAP and get a CAP waiver from DISA to stand up our own? Or is there some workloads that may not need to run at the IL5 level that could possibly go without a CAP? That's pretty rare. So typically it's DISA CAP or stand up your own. So as I jump into this, I just want to go over the terms again. I'm sure that if you're here, you've probably heard of SCCA, but I'm going to talk about it real quick. So SCCA and the CAP is actually a component of SCCA. So in the secure cloud computing architecture, there's 4 components. There's the cloud access point, virtual data center security stack, virtual data center managed services, and TCCM, the trusted credential manager, which is more sort of a business role. There are some technical requirements there just to enable them to be able to do their job and handle the identity and access management, but that's pretty easily accomplished with all the stuff that Azure and F5 offers. So this is what I'm not going to go through all these requirements. I'm just going to illustrate some of the important things here. So like detect and prevent malicious code injection. This is for boundary CAP requirements. So that's another key factor here. So when you hear CAP and you read SCCA, you're going to see that there's an ICAP, which is an internal CAP, and then you see a boundary CAP, which is a boundary cloud access point. The boundary cloud access point is for connection to public cloud or commercial cloud. So if you're connecting to Azure or you're connecting to Google or AWS, you will use a boundary CAP between the DISN and the cloud provider. The ICAP is for on-premises or for private cloud. You can think of like MilCloud. They would have an ICAP in front of it. So those requirements for an ICAP aren't actually a requirement if you're going to connect to Azure. So just be clear on that when you're looking at the requirements. You've got the 13 boundary CAP requirements. And this is what DIS is doing at their CAPs right now. Then you jump into the VDSS stuff. In my opinion, this is like the bread and butter of SCCA. The boundary CAP stuff is pretty self-explanatory. It's kind of you think of like a firewall, a boundary security. It's basically what it is. But the VDSS is where they have a lot more security controls. They want reverse proxy capabilities, break and inspect of SSL and TLS communication. This is something pretty specific to the DoD that you guys are trying to do. Obviously being able to look at inside every single packet and do your analysis. And we need to be able to provide that. So that's where, in our architecture, that's how come we have, I'll show you, but we have kind of a sandwich of F5 so that we can see the visibility in between them and in a clear text and pull that out as needed. And again, you'll have access to these slides, and the documentation shows it anyways. VDMS requirements, so this is more managed services. This is a lot of shared services. So you think of ACAS or HBSS, or if you're doing ADFS for your Active Directory Federation, or any other kind of services that every single mission owner application is going to need to actually have access to and share, you would put that in the VDMS. And they do call out some specific things that it needs to be able to do. So we also have that called out in our architecture. This is some stuff that you guys will eventually have to bring to the table. It's not part of the template for the most part, but we put a little area for you to drop that stuff in there. So now we get into secure Azure computing architecture. What is secure Azure computing architecture? Well, it's SCCA compliant architecture on Azure. So we wanted to kind of brand it so that you know off the bat that this is Azure and it's our SCCA version of a cloud architecture here. And so I'm going to talk a little bit about how we designed this. So SCCA compliant deployment, it meets boundary CAP, VDSS, and VDMS requirements all virtually in the cloud. It's deployed using currently available IL5 services within our DoD cloud. You could also, we do have some services that are available at IL4 that could supplement it. And once those services keep getting accredited up to the IL5, we'll have more and more capabilities as time goes on. It's an automated deployment, and overall, it's a reference architecture. So even once it completes, we like to say it's kind of like 80% complete. So different DoD entities have different different requirements specifically. So Army might be doing one thing, Marine Corps might be doing another, Navy might be doing one thing. So once it deploys, there is still some work to do, you know, and you also have to bring some of the stuff for VDMS. And then there's some stuff that you're specifically going to want to do. And of course, we have a bunch of resources to help you as you build out the rest of it. But it is a reference, and it's pretty modular, so you don't have to use everything. You can use parts of it. You can change it up a little bit, and I'll talk about some of the different options that we see today across our different customer bases. So this is probably the most common scenario here. So this is an on-premises boundary cap with Azure hosted VDSS. So you could think of this right here as the BCAP, which is DISA, right? And so they'll get their connection up to DISA with a service that we call ExpressRoute, and I'll talk about that in a minute. And then the actual VDSS and VDMS stuff will actually live over here in the cloud provider. This is typically the quickest path to get this done. Because you don't have to worry about the on-premises infrastructure for the boundary cap, and getting connected to the DISA, and then getting a cap waiver to actually do that. Then we have the Azure-hosted VDSS, BCAP, and VDMS. So this is where, at your data center, for if you're like Altez, you would have So you would have a direct fiber connection directly to your data center with ExpressRoute, and then all that boundary cap functionality would be getting done there at the in the cloud, so that you can kind of scale a little bit quicker and all that kind of stuff. This is a model that the Marine Corps is looking to do. They've gotten their cap waiver. Their edge routers are already meeting BCAP requirements, so they're just going to run it to their own BCAP, and that's definitely an option for the Army as well. So the VDSS portion here is essentially we've got the client that's all on premises. You've got two external F5s with an Azure load balancer in front of it, and then an IPS VM, which can be dropped in there, whatever IPS you decide you're going to use. And then that'll pass through, and then you've got another Azure load balancer balancing to the two internal. Those are like an HA pair, so one's active, one's standby for high availability sake. So in there, that's where you're going to be getting the SSL break and inspect. You're going to have CAC authentication enablement through the F5s, web application firewalls, network firewall, all that cool stuff. IPS, so the IPS stuff, that's kind of, you bring whatever you want to bring. It doesn't matter what vendor, whatever you're comfortable with. The Navy has a specific one they have to use for their policies. Army might have a little bit more freedom. So we just drop a Linux box in there as a placeholder for when you're going to bring something in.
If you notice the ALB here, a lot of you guys that might be familiar with F5 might know F5 as a load balancer. If you see the ALB, we're not doing the load balancing here. We're acting as a security appliance within the architecture to help meet those requirements. And I'll talk about a lot of the cyber functions that we're performing in that architecture as we get to those slides. But I just wanted to point that out before we move too far past it.
All right, thank you. So the VDMS, this is where you're going to drop in if you see, like, if you have WSUS or SCCM or ACAS, backups, OCSP responders. All that traffic for VDMS is going to be routed to this internal big IP. So all traffic from external, internal that you're going to need to do, like ADFS over that link, everything will pass through that stack, so you'll be able to see that traffic. And then any time it's going to actually communicate with applications that live down in the mission owner space in the cloud, it'll also pass through there. So this is just demonstrating the high availability aspect. So you see, like, if you lose this F5 right here, you're going to be fine. You'll transfer the second F5 and vice versa on the internal. So this is just standard high availability. SSL visibility. So this is how it comes in. So the encrypted traffic will come in SSL, terminate here at this big IP, pass through the IPS unencrypted visible traffic, and then re-encrypt it off the back end to your actual application. And then that IPS will pass it to whatever tool you're going to use to actually aggregate those logs and actually do that analysis.
Yeah, I want to add something right here real quick. So what makes F5 pretty phenomenal in this specific function is that we own some very powerful intellectual property that allows us to do this SSL visibility in a very unique way. Reverse proxy inbound traffic is a very common practice. It's standard. We've been doing it for the past 20 years where you can offload SSL, hand traffic off to a server. The forward proxy is where a lot of the magic happens, because in that process you're having to impersonate the endpoint that users are going to. This is allowing you to have visibility into encrypted traffic outside of your network. As users from inside or applications inside your network reach out, we're able to generate a trusted certificate for the websites that they go to using existing trusted PKI infrastructure within your environments, without having to build your own CA, without having to do something crazy, without having to trust a self-signed cert from F5. You're able to tie this to the existing Dod and PKI.
So, key Azure services. I'm just going to quickly say what these things are. If you want to learn more about the details of these services that are used in the architecture, my contact information is going to be on here, and just hit me up and I'll send you some stuff. Also, if you literally just search online for these terms in Azure, you'll find some pretty awesome documentation where it's pretty easy to find information. I'm actually pretty impressed by our documents. So, virtual networks, that's the actual construct. That's where the address space is going to live. That's where automatic segregation, it's sort of like a VLAN on premises, where you actually inject the address space. Every single thing is going to live inside that virtual network, and you won't be able to communicate across virtual networks unless you set up a layer 3 connection between those. Subnets live inside of there, the way we kind of implement it. So if you're looking at like a VLAN, it's sort of like a secondary IP address. So all those subnets that are inside that virtual network will be able to communicate to each other directly, unless you tune the routing to actually go out through the F5, which is what the user-defined routes that I'll talk about here in a second. Express route, this is pretty key because this is how you're actually going to connect to the cloud. This is a dedicated fiber connection. So you can get up to a 10 gig circuit. When you get that, you actually get 2 fiber pairs, and it connects directly into the DISN, and essentially the DISN becomes connected to the Microsoft backbone. As soon as you hit the Microsoft backbone, you are on the Microsoft backbone forever until you leave Microsoft. If you're connecting to something that's in Asia, it'll ride the Microsoft backbone on our high-speed network. That's one of the differentiators between us and our competitors, is that it's more secure in the sense that it doesn't actually go over shared fiber once it leaves a data center. It's all ours. If we were an ISP, I think the number right now is we would be like the second largest ISP in the world because we own so much fiber. And a lot of it's not being used. So. VPN, this is standard IPsec tunnels, which you can use to connect actual misdemeanor applications up through the VDSS stack. But you can, if you're in different regions, or you can do VNet peering, which is the virtual network peering, that layer 3 connection, which is a lot quicker if you're within the same region. User-defined routes, this is just like a static route on premises. So this is how you're going to actually force traffic to route through the stack and back and onto on-premises without going around it and all that. This is probably one of the most important pieces to actually make this architecture work. Availability sets are what we actually put the virtual machines in. This is for availability. So you could put, what we do is we put the internal F5s into the same availability set. If you scale out like 10 of them, you can have them all in the same availability set. But that one virtual machine, depending on how you set up, you can, the default I believe is 3 and 5 for fault domains and update domains. So what that means is that one VM will actually live across 3 different physical racks with 3 different power supplies. So like if we're doing maintenance on a rack and we take that down, your VM's still going to be there. And you can bump that number up if you'd like. And so that's pretty key. And that's something that once you create a VM, you can't go in and create an availability set and put that VM back in it without shutting it down. So it's key that in our architecture, we create an availability set for every VM we put into it so that it's there ready for you as you want to do it. Network security groups, this is just like an access list on premises. That's port, IP, destination, source, deny or accept. We implement some of that stuff around the architecture to kind of lock down some common stuff, and you can obviously tune that to how you want to do it to supplement what F5 is doing already. And then Azure Load Balancers, we kind of talked about the use of that is so that we can have one endpoint to send our traffic to, and a load balance to whatever active F5s are online. So this is probably the most important thing here. So who should deploy this architecture? I wouldn't say that it's good for everybody, right? So if you're just an individual application owner, you have one mission owner, you're just going to create one application, then DISA's offering a VDSS. It kind of looks just like what we're doing here. You might want to subscribe to that, and then maybe put some, like maybe one F5 or two F5s at your boundary just to control some stuff internally. But realistically, there's not a whole lot of people that are doing that. The key is managed service providers. So like your TradeOps or your Altez's that host applications for people across the DoD today. They can stand this up in their environment, and now they control the connection to all the mission owner applications. So instead of having to go buy an express route connection to DISA, they go over an enterprise shared circuit, and then the connection to this stack is a virtual connection that they can stand up, and Altez or TradeOps will control that. And then organizations that want to have a direct express route to their data centers without routing all over the DISA. So like right now, if you connect to the DISA CAP, you get you get an express route through them. You're actually sharing that express route across the rest of the DoD. And then of course you've got to bounce around the DISA to actually get to where you live. There's a lot of latency that gets involved with that. So if you want to go direct to it and have your own CAP with a CAP waiver, those are also customers that are prime candidates to actually deploy this. And we can go into more detail if you guys like later on, if you guys have questions on some decision points. But I'm going to hand it off to Michael to talk about F5 now. Cool. Thanks.
All right, so how many non-former F5 employees in here have experience with F5 at all? A little bit? All right, so there's a lot of pieces that we add within the cloud architectures, whether it's SCCA, through Azure or another cloud provider out there. Lessons learned for us is that I've seen a lot of customers come back to Azure. A lot of the terminology and stuff, the networking piece of Azure is a lot simpler than a lot of the other cloud providers out there. So we've seen several customers meet with Microsoft, get this whole secure Azure cloud architecture down, get it documented, get it designed, try to implement it somewhere else, and it becomes very complex and difficult. Within this architecture, there's a lot of pieces that we add. One thing that I'll point out is within the slide so far, you've seen how we've mapped specifically along the F5 product line to the SCCA requirements for deploying this use case. One thing that we also point out in a lot more detail within the federal team is how we align specifically to the compliancies as far as FIPS was mentioned, STIGs, all of the different hardening that has to happen within that environment. And what the F5 gives you in virtual, as well as our physical devices, but specifically virtual for the cloud, is that you have a certified compliant boundary to perform a tremendous amount of security functions on all traffic traversing your network. You have a FIPS device, you have an APL certified device, you have a completely hardened device that allows you to provide a network access firewall, the web application firewall, which is a point where we often lose focus within the DoD, and we've been trying to educate and provide more guidance to step above the standard IDS, IPS network firewall scenario and look at where all of the breaches happen today. If I'm an OPM or I'm a DCMA or I'm a Pentagon, my breach didn't happen at the network level. My breach happened at an insider threat, an accident, a coding mistake, a bug that lived within 5 through 7. So these are really our wheelhouse when we're talking about the services that we provide in these architectures. App security we've talked about quite a bit. We have built-in protection for DDoS. This doesn't sound that great. A lot of times customers within DoD don't want to talk DDoS unless you're a PAO office. You have an IL2 site. You have a public affairs site. You have a recruiting site. Those sites receive hundreds of thousands of DDoS attacks a day. Now, if you also consider that those aren't going over commercial links, those are coming across Dod networks, those are bogging down the networks, creating more and more latency. I won't name names, but if you're using any of the current stacks to connect to the internet and you have a tremendous amount of latency added to your network over the past year or so, it's because of the IDS, IPS is getting bogged down from the amount of traffic traversing those systems. App access and identity is very large for us today in Army as we look at moving away from role-based access control and we look at attribute-based access control and a zero trust model. If you guys aren't familiar with zero trust, it should start coming up more and more recently. If you're not familiar with the Google model and the Beyond Core model for zero trust and how they're accomplishing things that we are trying to accomplish in the DoD as well, just not moving as quickly. You can't have these massive Active Directories that have every single user. It becomes more dangerous to have things like a publicly accessible DIRs where I can pull every single attribute about any service member that I want. Where I can have systems like OPM that have my information and any clearance holder within the government for the past 20, 30 years. I know your social security number. In one of my presentations, I pull up an actual screenshot from the dark web that shows that I can go out and buy all of your credentials for like $12. And get a full pack download. That's a real number. $12, I can get, I think, 100 users. Usernames, passwords for every site that your email address is linked to. That's significant. So as we move away from the username and password, which we should have done in 2005 when that requirement first came out, and as it comes out every couple of years, forcing us to use CAC, to use PIV, to use soft search, to use biometrics, to use wearables, to use ingestibles, to use all of these different token-based, what do I have, what do I know, where should I be, those sorts of things. You need a solution that's not reliant on middleware, that's not reliant on your operating system, your location, especially when you're talking about warfighters. You need to be able to quickly adjust and provide access based on identity, location, context, and all of these attributes that we can gather to determine who you are, what device you're accessing from, where you're accessing from, and what level of access we give you to this system. Not just assigning an IP address to your machine so you can connect to any device on the network. I believe, so I mentioned Doug, my account manager in the back. We had a meeting with a customer recently that had no interest whatsoever in screening any of the internal traffic. They wanted to focus solely on external inbound traffic to their applications. And my question is always, why? If you look at the breaches that have happened, if you look at the Snowdens and all of the different things that have happened over the past half a decade, they've been insiders that have made mistakes. They've been developers that put a net use share in Cold Fusion that opened up an entire file share within the government. They've been accidents where somebody has left a CAC in their machine and walked away. They've been situations where somebody left a laptop in their car, and that laptop was taken because they thought it would be a good idea to log in with rights and remove it from the domain, but still maintain all of their documentation on there. These are things that can be prevented. These are things that we are helping prevent in a lot of this architecture. While this isn't on-premises scenarios where we're able to sit on top of a machine, we're able to protect the cloud environment. We're able to protect this connection to the cloud to make sure that who is connecting is who they are, where they're supposed to be, on the devices they're supposed to access from. The industry as a whole is also moving away from a lot of the VPN technology, and they're moving towards this zero trust model where it's the attribute-based access control to specific apps. Again, I'm not giving a user an IP. I'm not giving you access to my network. I know who you are. I know what groups you might be part of. I might know all the information from your attributes on your CAC or your PIV or your SIPR CAC or whatever you're accessing with. I can use that to build the level of access you get to the apps that I'm willing to give you access to. Not just this sort of lazy administrator, you've got this app on your laptop, you connect, now you're on the network, do whatever you want, have access to all the apps, whatever you can get to. And then the big one is availability. If you're not familiar, as familiar with F5 as I want to make you, you should really do some research on F5 and see where we've evolved to over the past 5-10 years. A lot of people know F5 as load balancer, and I pointed that out earlier. And there's a lot of times we have customers, conversations with customers, and they just say, the load balancer. And that's sort of an antiquated terminology for our core function. Yes, the F5 is a load balancer. It's what we grew up doing. But the industry as a whole has moved away from sort of load balancing. You can go out to the internet and download a free load balancer that will be okay. You can't go out to the internet and download something that provides you identity federation, endpoint awareness, context awareness, all of these sort of cloud-based scenarios that you need to adapt with. F5 as a whole is also not completely moving away from hardware, but putting a lot of focus and development into cloud. A lot of people have come by our booth over the past couple of days, and one of the things that I've pointed out is you're never going to see F5 in the airport. You're never going to hear an F5 article on the radio unless you're listening to like federal NPR or something like that, where we have our guys come in and speak about it. Or if you come to one of these tech talks. And the reason for that is because we take all of that money that these other organizations spend on advertising and we put it directly back into research and development. We direct it to our teams that are focused on compliance and certification and hardening and security to make sure that we are a step ahead of the rest of the industry as we progress to cloud-based environments. If you trust Gartner and you look at Gartner, we are the lead for all of the things that we do. Forward web proxy, reverse web proxy, secure web application, firewalling. We now have a product called Advanced Web Application Firewalling that includes layer 7 DDoS attacks. As we try to evolve in IT within the DoD, and it's a very slow evolution in a lot of the DoD environments unless you're part of a cyber command. Moving the needle can be very complex, but our attackers are progressing at an exponential rate from government-funded attacks on a daily basis. If you're not subscribed to US CERT, if you're not subscribed to F5 Labs, if you're not subscribed to some of these news groups, you're not seeing the 0 days that are coming out that are all focused on SSL vulnerabilities, on SQL injections, cross-site scripting, forgeries, things like that. We do a hack and patch at F5 to show how simple it is for me to break into any of your applications just by using Chrome. I don't need a Kali installation, and I don't need special tools, and I don't need a special Linux box, and I don't need magical powers to break into your system. I need Chrome in about 5 minutes. And I can start breaking into your system. I can start phishing. I can start injecting JavaScript. I can start taking down your systems. And one of the reasons that we talk a lot about DDoS at F5 is because the DDoS attacks are not what you should be focusing on. The DDoS attacks are a magic trick. Watch my hand over here while I come in from behind you and steal your wallet. And that's generally what happens. I'll bring down your network. I'll have somebody inside. I'll have another backdoor that while you're patching this, I'm able to steal all of your information. Some of the cool things that we're doing now are allowing a lot of seamless upgrades. We have one tool that was mentioned. I tried to fit in a slide. It just didn't work in what we were trying to present today. But we've got a lot of features focused on, again, cloud. So we have specific cloud editions. We've got FIPS virtuals that run in these clouds. Some of this is not available yet in the marketplace. You have to bring your own license. But it is absolutely available to you in a subscription-based method. So instead of having to dedicate your resources to purchasing hardware or purchasing a large upfront sort of scenario, you're able to get a subscription-based solution based on utilization of the platform. So if you're looking at a secure cloud computing architecture and you want to pay based off what you use, that's where the industry as a whole is moving. You don't have to go out and buy $4 million worth of servers and storage and switches and routers and things to upgrade your antiquated infrastructure. We also have management tools at F5. If you're not familiar with BigIQ, if you're only familiar with BigIP, I highly recommend you reach out to Doug and myself or Mary to get some visibility on BigIQ. It's a very powerful centralized management tool that allows you to manage security policies, to manage SSO, identity and access management, security. Did I unplug your laptop? There you go. Sorry. To manage all of the security policies. So I can centrally manage firewall policies for the entire enterprise. I can centrally manage the identity and access management, the multi-factor access across the enterprise, and push it out to every single one of my devices. Where this becomes extremely powerful, especially in cloud, is if you are an SCCA provider, an SACA provider for your mission owners. You're able to roll out configs to their devices. You're able to push how you want them to authenticate to your environment very simply, using JSON, using XML, using BigIQ Centralized Manager to manage updates, manage IAVAs, security patches, things like that across the board. And one last piece that I'll add here, this is my last slide, but I'll throw in some more notes, is that when you think about F5, if you only know F5 as the load balancer, I want you guys to take away that the F5 is a very powerful, hardened, compliant platform. not just for security, but for availability and DevOps. On Box, we have the ability to support DevOps-type solutions inside of the boundary. So if there's something that the F5 does not do for you today, your CAC authentication, your radius authentication, your biometrics, your whatever, within 5 minutes, I could deploy something on the F5 to support whatever that use case might be. An example of that, which it's actually taken them more than 5 minutes, if you guys aren't familiar with privileged user access, there's guidance from DISA. There's solutions out there where we can translate any sort of authentication that you need, CAC, PIV, ECA, radius, biometrics, to an ephemeral password using our zero trust model to any of your legacy systems, switches, routers, Sun Solaris, Linux, whatever, and will also work in this cloud environment as well. And that all lives inside the F5. And what that essentially does is it gives you a hardened network device that becomes your Dropbox that can proxy SSH access, that can control the level of access to the management devices within your environment. And since it's cloud, you can easily spool off these devices so they don't reside on the data plane. They reside on the control plane that give you direct CAC or PIV, whatever, into that environment. And one of the scenarios that we worked with specifically was to eliminate a requirement for you to have PuTTY, for you to have secure CRT, for you to have any other SSH-type client tool on your device, which you can absolutely use. We've got native support as well. But it gives you an MFA access via HTML5 all through the browser. So you can multi-factor into your switches and routers through a web client. The system is so powerful that it also allows you to do not just a, we call it ephemeral auth, but not just a one-time password for those that are familiar with Secure ID or OTP using Google or whatever video games you might play that use the tokenized auth. We can also do one-time passwords for executions of apps. So every single execution, an ephemeral password is generated. The app is run, password is generated again, user never knows it. Password never exists at that endpoint. And it gives us the ability to proxy authentication to those systems, LDAP, Radius, TACAX, whatever, so that we're able to capture those binds. We can see what's happening. And that, what we found is that actually has given us another visibility into the environment where if there's ever an invalid password that's traversing the F5s, that's somebody trying to hack your network. Because the only way that anybody would ever enter a password in that scenario is if they're trying to bypass our privileged user access. And that password would immediately be declined, even if it matched Active Directory, because we're trying to catch that. So there's a lot of power that this gives you. That's all the stuff that I want to talk about with F5 in this environment today. If you guys, again, have any questions, we're here to answer or go as deep into the weeds as you want.
So, so the demo, we're going to look back at the demo and see how this has gone. So, but he touched on the like lateral movement within your cloud environment instead of internal external, kind of moving left horizontally, and what F5 can do for you. One of the other things I just want to touch on is that there are native tools within the cloud that also can be used with that in conjunction with F5 to really give you a better security posture. And one of them is called Azure Security Center. And it's essentially enabled. You just literally have to click one button and enable it, and it'll show you all the different resources you have within your environment that if they're virtual machines, you need to install the agent. It'll let you know if that's happened. Once you do that, you have all kinds of telemetry that you can see and actually start seeing different signatures of different attacks, and it's all backed by our like intelligent security guide. This is like a whole 2-hour conversation on its own. But I'm just going to give you a quick down and dirty. But there's like the intelligent security graph that ties into our CDOC, which is our defense operations, cyber defense operations center up in Redmond, Washington, at our headquarters, where every single thing that comes from Windows box all across the world, all these attacks, all these signatures are being pumped into the security graph, and you're getting that in Azure on any workload that's actually running in there. To demonstrate the value, I'm sure everybody's seen where we just announced that we caught Russians trying to hack our like midterm elections or hacking Republican systems and all that stuff. We found that from this intelligent security graph. This is stuff that that automatically gets pumped into Azure for you to consume as a service, and that will look at everything within your Azure environment to be able to see all that kind of stuff. So it's pretty cool, and it's pretty easy to enable, and again, that's something that we can talk about if you guys want to talk about it later on. But it's and it feeds, and anything that comes from F5 will pump right into that also. It's almost like, it's sort of like Splunk with log aggregation and all that kind of stuff. So it will work in conjunction with F5.
Yeah, I had one more note to give you guys. I thought of it as Jason was mentioning that. One thing that's been extremely popular with our federal customers, we have a tool that will allow you to directly import ACAS scans into the F5. If you're doing PVS scans where you've got constant scans running on your network, we can take that XML directly from ACAS and patch at that tier so you've got more time before you have a struts type situation on your hands. A lot of times we get the notifications, we have to wait for patches for servers and things, but as soon as the F5 knows about it, the F5 can patch that tier and prevent those vulnerabilities from ever reaching your servers. That one is extremely popular. Even the FBI is evaluating that right now. To be able to take scans, initiate scans directly from the F5 using REST, because all of these systems have open APIs where you can do things via scripting or coding in whatever language you're comfortable with, especially using JSON to build out these templates for an entire virtual environment, but you can connect all of these systems. I can receive a device that I don't trust through the F5, and I can say, hey, ACAS, run a scan on this device. Send me the results from what you pull back on this scan. How do you want to respond to these scans? And it all ties together with the security architecture that Jason's talking about as well.
Yeah, so I'm going to show you, actually, this is a rarity in demo world, so this is a huge deal right now. Everything went well. It has completed. So this, yeah. Well, it's usually something happens. I mean, I'm doing it on my phone. And so the TechNet demo resource group, this was the first resource group that I typed in, if you guys remember. This is what deployed all the Azure infrastructure that is key. And it looks like a bunch of stuff. You can see here the type. It's load balancers or availability sets, route tables, network interfaces, virtual machines. This is the IPS VM, if you can read that back there. But then it kicks off two other resource groups, which was the TechNet demo, the actual external F5. So this is where the two external F5 boxes are going to live. Has the availability sets, the network interfaces for the devices, and the virtual machines in here. So all this stuff is configured, and then once that's done, using some other tooling, Ansible playbooks, it will link into an actual configuration script that F5 wrote for the actual policies on the devices. Now, the internal F5s, it has the other resource group that gets populated and deployed all this stuff. So like I said, this is all the resources that were deployed, and as you can see, I mean, it wasn't that long. I mean, we're 40 minutes into the presentation, and the whole infrastructure is completed. I'm going to go to the next slide. I'm going to show you the diagram, and I'll point out what these things were, so it kind of resonates. But the whole point is that if you're going to deploy these types of services on premises, this is a huge life. It takes a long time, and it's a huge process. I mean, you're rack and stacking devices. You're doing all the procurement of the devices, which could take forever. Then you're laying fiber or whatever, what have you. Then you got to configure them, and it's a big process. And I would say, typically it's not a quick thing. And if you really dig down and do it, once you have all the stuff, it's going to take you at least a couple weeks to get everything up and running to the point where everything's routing correctly. Because that's the other key, is that the routing's already set up. The very last thing that happens is it forces all the traffic through the device, and it works. So I think this is a pretty awesome thing, because as you guys go, every single customer across the DoD is going to have to be compliant with its SCCA one way or another. And what we've done for you is really make this a lot quicker for you to get started, because you can go deploy this. You could literally, if you guys get some F5 licenses, you can go to our documentation. That's literally what I just did, and you can deploy this in your Azure environment today. And then you can start getting into the really deep details of actually making it happen. I know that you've got our competitors out there for cloud providers there. You can certainly stand up the same types of architectures on theirs, but you're not going to get this automated deployment where you're going to be doing all this by hand jamming. And this is going to get you started, and it's pretty foolproof, and it's got support from the team that created it. So I'm going to show you the diagram real quick. Let's do it one more time. So this is sort of our technical diagram that shows the different services and how it's all routing. So what was just created is this virtual network at the top. These represent mission owner applications, IL5 mission owner, IL4 mission owner. We've also created some PowerShell scripts that will kind of get the outlay of this set up and connect it to this internal F5 so that you can kind of get your mission owner application environment connected in a compliant way. But really, every single application is going to be built a little differently, so we can help you to kind of build automation into that. But the key, so here what's created is we've got the Azure load balancer, which I talked about there, the two F5s, the IP that is going to be connecting to for your actual endpoints. Your user-defined routes are these little red lines. These are actually what's pointing traffic to and from and through the device. So if you actually follow the red lines, you'll see that from VDMS subnet over here, everything flows to this floating IP out through here, through the IPS, and vice versa. So in this little stack right here is where you're going to see your clear text, and then you'll be able to pump that into Azure Security Center, or if you have some customers are using Splunk or whatever, what have you, you'll pump that information into that'll live over here in the VDMS. We've got some jump boxes that are deployed. These are virtual machines that are for like remote desktop gateways, or just jumping in the environment. They're sort of management bastion hosts so that you can ensure that you're not getting, it's kind of out-of-band management, I guess you could say. And you got your internal F5. So all of this stuff, this full security stack architecture up here, that was just done while we were talking. So I'm pretty proud of it, and I'm pretty thankful for the partnership with F5 on doing this. But that's really all we have. Again, there's a lot. This is a huge conversation as you guys are trying to get connected to the cloud and move applications. This will probably be where it begins. The first questions are, I guess it's telling me I'm done. So the first questions are, okay, how do I connect? How do I stay compliant with policy? And how do I secure my environment? And it'll all center around this. And so if you want to have more in-depth conversations, please just reach out to our account teams. We can come down and do that. We can help you design what you need to design. F5 also will do the same thing. And I appreciate you guys coming out during lunch, so lunch hours. But that's all I have. Great. Yeah. Yeah, I'll email it to you later today. Absolutely. Yep. And again, I'll send you it has the links to all our blogs and all that stuff. It'll be helpful too. Okay. Yeah. All right. Thanks, man. Yep. Yeah, so if it's in this will be sent out, but if you actually just go to the blog and you go to the documentation, it's got the link to it that you just click and it'll deploy into Azure. Yeah, it's on the documentation that I deployed it out of in the demo. If you want like licenses to be able to deploy the F5, you have to have a license for the F5s, like trial licenses. You have to talk to the F5 guys and they'll be able to hook you up. Good. Nice to meet you. Okay. we tried to make the technical part as easy as possible. But yeah, we could definitely talk about it. Our account team's standing in the back somewhere. The guy in the blue shirt and jacket, he's one of the guys that works with you guys, and he can bring us in as needed. We can talk about that. It's definitely, I see definitely value in pulling training stuff into that. Marine Corps is trying to do that too. So. Yeah, they're moving pretty quick. So. Yeah. No, I live in DC area. Yeah. So yeah, we could talk about all that stuff. And the other thing is, like, if it's training data, you might not need that classified at IL 405. If it's just training data. So if it's just training data, yeah. So if it's just that kind of stuff, you might not even need to worry about this for your actual environment. You might be able to collect it directly to the internet. You might want to stand something like this up for like a DMZ. Yeah. So what we do is with the RD gateway, it's all 443 traffic until it hits that box. Then it translates it to 3389 coming out of that box. So like all your VMs internally, it will do like a network security group that says 3389 traffic can only be accepted if it comes from that IP address, which is that jump box that is the RD gateway. So that'll get you through the DISA through on 443, and they'll allow that, right? And that's how you can remote desktop gateway. We said the same thing for Army Corps of Engineers is doing it, and they're on the DISA. So like TradeDoc right now is actually working on deploying this. So the idea then would be that you don't have to worry about it. TradeDoc would do it. You would be the mission owner application behind them. You'll just route your traffic through them. So that's kind of what's going on. TradeDoc should be able to help you guys out with that if they set this up. That's the whole idea behind it, is that you just have to do a virtual connection in Azure from your Azure environment to that, and then they control everything else. Yeah. They're running out right now.
I mean, so we hear a lot of vendors, like, especially if you're your feds, like, we're all actually friends. The guys that aren't and try to talk shit, so those are the guys who aren't part of the federal family, because like, I know the guys down in Palo Alto, like, they're part of the Air Force Tech, I know the guys at Force Scout, we all talk good. So you know the guys
something? Oh, yeah. How do I get you the slide thing?